Turning natural gas into LNG is one of the most demanding feats of industrial refrigeration ever attempted. What begins as an invisible gas flowing through a pipeline must be transformed into a cryogenic liquid cold enough to rival the temperatures found on distant planets. The process begins when natural gas arrives at the facility through massive pipeline networks. Before it can be cooled, the gas must undergo an intensive purification process. Water, carbon dioxide, sulfur compounds, nitrogen, and even microscopic traces of mercury are removed. At ordinary temperatures, these impurities are harmless, but at cryogenic conditions they would freeze into solid crystals, blocking pipes, damaging precision equipment, and potentially shutting down the entire plant. The purified methane then enters the heart of the facility, the liquefaction train. Far from a simple processing unit, a liquefaction train is essentially a gigantic industrial refrigeration machine operating on a scale few other industries can match. Each train contains miles of piping, towering process vessels, massive heat exchangers, and some of the world's largest rotating machines. At the center of the operation are enormous compressors, often powered by industrial gas turbines similar in size and technology to aircraft engines. These machines consume vast amounts of energy as they compress and circulate refrigerants through a carefully controlled cycle. By repeatedly compressing, cooling, and expanding these refrigerants, engineers create temperatures cold enough to transform a gas into a liquid. The final cooling stage occurs inside the main cryogenic heat exchanger, a massive piece of equipment often taller than a building and made from highly specialized aluminum alloys. Inside, thousands of streams of ultra-cold refrigerant flow through precisely engineered passages, pulling heat away from the natural gas in a series of increasingly colder stages. Eventually, the methane reaches approximately minus 162 degrees Celsius, a temperature so cold that steel becomes brittle and ordinary materials fail. At this point, the gas molecules slow down enough to collapse into a liquid. The transformation is dramatic. The natural gas shrinks to roughly 1/600th of its original volume, turning an enormous cloud of gas into a dense, transportable liquid. At facilities like Sabine Pass LNG, this process is repeated across 6 massive liquefaction trains operating continuously. Each train is a self-contained industrial complex capable of producing around 5 million tons of LNG per year. Together, these trains consume enough natural gas to supply millions of homes while converting it into a form compact enough to be loaded onto specialized LNG carriers and transported across oceans. Behind every shipment of LNG is a remarkable chain of engineering. Thousands of tons of equipment, hundreds of miles of piping, powerful turbines, precision control systems, and refrigeration technology pushed to the limits of what is physically possible, all working together to turn the simplest carbon unit, methane, into one of the world's most important energy commodities.